Here's an example of capping some complex 3D surfaces. I'm going to do one as an example so you get an idea of how to do the rest of them. So we'll come in here and we'll do the counterbore, the center hole first. Now pay attention here. We have the hole is going through the slot. Watch how nicely we restore the slot. Okay, so from there I'm going to take us over into EZCAM. Alright, we're going to position our coordinate system at the top of the model in the center. We'll create a roughing pass, but let's take a look at the diameter of that slot. You double click on the radius and we have a diameter of 0.55, so we can fit a 1/2 inch cutter in through there. We're going to go to the wizards, 3D machining. We'll begin with a roughing work step. I'll choose pocketing. The path is automatic. It's going to be based on the surfaces I select, or EZCAM automatically selects all surfaces for us. The path offset, I can go beyond the part boundary by the tool diameter. There's nothing in the way. Flat end mill. Let's go with a 3/4 tool. As for a Z step, I'll be aggressive at 1/4 inch. That'll carry us down step by step into the cavity, so I'm going to use a step finish of 30 thousandths to machine just up against the wall. It's not going to machine the entire part at that level. We're using high-speed machining. Step over 50%, and we'll put in a finish allowance of 20 thousandths. And as you can see up against the wall, there's our 30 thousandths. So the next operation I'm going to create is machining this slot. That's a 2D operation. Tool number 2. I'll use a 3/4 inch cutter. I'm sorry, a 3/8 cutter. The depth, EZCAM's going to detect that when I select the bottom face. I don't want to machine with a 3/8 cutter at full depth, so I'm going to go in and step down every 1/8 inch. I won't leave a finish allowance. I'm going to use HSM, which gives me the option of using a finish pass. Select the bottom face and verify. Now EZCAM was smart enough to know that even though our surface is 0, it's going to skip down. All the material has been removed and it picks up the start height. So I'll just use rapid cut. Next, I'm going to machine the vertical walls. That'll be a 2D contour operation. Tool 3. I use a 1-inch cutter. You can calculate your speeds and feeds in the background. If you go to advanced, I'm going to hit calculate surface, and that's going to be at the top of the part is where it starts. This will clear us out of the part. Depth is 0. EZCAM will detect the depth based on the vertical walls I select. And we'll get rid of the Z step. I want to switch over to multiple passes. Total stock I'll say is 1 inch. And a cut step of 1/4 inch. Now these parameters are going to change based on the type of material, machine rigidity, your preferences. So I'm going to use a lead in and lead out. EZCAM gives us some default values, which I will accept. Now with Smart Click, the magic wand, I click one face. EZCAM chains all the faces together that make up that contour. There's our lead in and lead out, multiple passes. Now let's say I don't want to machine this face, it's already been machined to size. I'm just going to select surfaces. Now if I select that face, it turns off all of them. So what I'm going to do is use the shift key, hit it once, select that face. Now it's not selected for machining. Now if I want to machine that contour first, if you click on the operation in the list box in the upper right, use the left arrow key to make that the first operation. Use the right arrow key to bring it back down, and that's where I'm going to leave it. Now we're ready to remove that 30,000 step against the walls. I'm going to use 3D machining and create a finish pass. Equidistant is the best tool path we have to offer. It gives you a nice uniform step no matter what the surface slope. If I use 0 or tool radius, EZCAM treats it as a pocket and would stop the tool at the center of the edge of the surface. If I use less the diameter, EZCAM takes the ball nose tool or bull nose tool and brings it down to the edge tangent without dropping down or without being contained into a surface boundary. Switch over to the ball end mill. Tool 4. Use a 1/2 inch diameter. The step over, the finer the step over, the better the finish. I'm just going to use 25 thousandths to give us a real quick calculation. The tighter the tolerance, the better the finish as well. The program size is considerably larger. Our finish allowance is 0. Now we left 20 thousandths on our first pass, our first operation. If I was to leave 10 thousandths, it would remove those 30,000 steps and give me the ability to go in with a finish pass, which cleans up uniformly. Verify. Okay, if we zoom in, you can see that a 1/2 inch ball end mill can fit into the slot and machines down to the bottom. Well, I don't want to do that. I want to machine up to the edges, less the diameter, keeping a nice sharp edge based on the tolerance. We're going to exclude that slot. We'll select those faces. Now I could stop there. I just eliminated the vertical walls in the flat surface, and the ball end mill will treat it as it should. But I'm going to show you in cases where you might have other surfaces surrounding that you don't want to include them. So we make check surfaces. Make the operation aware of those surfaces without violating them. Verify again. Now we avoid plunging down to the bottom of the slot. Our part is now complete.